Hi folks, all things print this semester is looked after by Jeff A. Rugrock. This is heading into the second half of the Blueprints course, and for this one we're going to be taking some plan and elevation drawings and converting them into isometric. The scale is not applicable, except to say that I am going to be just drawing everything at half size. So I'm going to show you in a drawing in a moment. And what is 6 inches I'm going to draw as 3 inches. What was 2 inches on the drawing, I'm going to now draw as 1 inch. So I'm just cutting everything by half. And this is drawing number 22, and it's directly related to the sizing of the stacks we did in the first part of this course. There was stack A, stack B, and then a plan view with the building drain and the building sewer. Anyways, you can see I've got some dimensions here. So as I said, this is 6 inches on the inside. So I'm going to be drawing it at 3 inches. And that sort of, this was 2 1/4. So it's going to be drawn at 1 1/8. That's it for scale. Think of it as a custom scale, if you will. Anyways, we're going to draw this in isometric. There's not a lot to it beyond the detail box, which is what I'm going to start with. In fact, I'm going to do this in reverse. I'm going to do the plan first, stack B second, and then finally stack A. Not obligated to do it this way, but I like to start with a solid foundation, which simply means, for me anyways, starting at the bottom and working my way up. Because this has a general outline, I'm going to use this general outline, the 6 by 5.5 or 3 by 2 5/8. I'm going to use this as my detail box, and then I'll build my piping plan up from there. And a lot of the detail boxes we've been doing are three-dimensional. This one's not going to be, it's the green lines here. It's just going to be a flat one, but then you can see my building drain runs right through the center of the building with that horizontal branch going off to the side, and then the 2 stacks. Anyway, so this is my rough. I always have a rough to go along with my intended drawing. In this case, I had to work really hard to find the right size to fit. Anyways, so isometric drawing is a 30-degree angle. I'm going to start right here in the middle, down nice and low so we have lots of room. I'm not doing the vertical aspects of this detail box. I am merely doing the outline. But the same rules of the road apply here as they did to everything else. So this is going to be my 6 inch cut in half is 3 inch. And this one is going to be my 2.5 cut down to, or sorry, 5.5 cut down to 2 5/8. So horizontal lines only. I'm not going to embolden this because it's not the piping that I want to show. So it doesn't help with my design intent. It just helps me with my strategies for drawing. And what I've been referring to as spotting. So in this case, I know my building drain runs up through the middle of the drawing, which is at 2 3/4, which I can cut in half. So I just need to find that dimension. So we got 1 1/4, 1 and... So there we go. So that's the center line here. And that's where my building drain runs. From just outside the building all the way to stack A. And then stack A just goes up. So that's the stack that goes vertical. And I can embolden this line because that's not going to change much at all. Stack B is 2 1/4 inches down, so I'm going to make that 1 1/8. Again, I'm just going to mark it here and then draw it across. So I'm using the detail box to put all my measurements on. So 1 1/8. Now, here is the first trick to drawing isometric diagonal lines. And the term that I'll sometimes use is draw it square and shave it a hair. So you'll see that there's a 45-degree elbow here and then a Y fitting. So I can't just draw straight into this. In fact, you're not allowed to lie a TY down on its side. Remember, this is looking down. You can't have a TY here. It must be a Y. So when I say draw it square, I mean draw it just like at right angles. So this is an isometric right angle. And then if you go 1/4 inch that way and 1/4 inch that way, you'll have an equal 1 foot, well, 1/4 inch, sorry. You have 1/4 inch this way, 1/4 inch this way. So that means you've got 45-degree angle in between. And you will see that this 45-degree pipe looks vertical. I assure you it's not, but unfortunately, whether you like it or not, oops, the camera's in the way, it looks it. So there's stack B. So this is A, this is B, and this is 0.1 on the drawing. I suppose if you wanted to, you could also put a clean out, because it does show one here. And because that's the building drain, you also know it's 4 inches minimum. Okay, there we go. So this is what I call draw it square and shave it hair. You just draw everything at right angles. Then you create your 45-degree isosceles triangle here with the 2 equal sides. And then you know you're 45 degrees across. Anyway, so there you go. So there's that one. Next one will be stack B. And we have 1 1/4 up for branch D, and then 2 3/4 of an inch above that for C and B, and then the same again for A. So I will, of course, again cut those all in half. So 1 1/4. So I'm looking for 5/8 to the first one. Jeez. My ruler's not fitting in here. So 2 3/4, so that's 2 1/2, 2 3/4. So A goes to the left. This would be, B and C. B goes to the left, C to the right, and then D just to the right. These are in fact 2 3/4, so 1 5/8 out. Didn't quite draw this one far enough, did I? Remember, you only have to measure once, and then you can use that measurement in your T-square to make it identical all the way around. So the same thing for these. This has actually got a 45 with a Y and a short piece of pipe. Same here and there. So this is a single Y, a double Y, and a single Y. Anyway, so we just have to, again, this distance between here and this distance between here and here. So the inlet of the Y and the distance between the 45 over is equal. So if this was 1, this would be 1, this would be 1.4142, right? So there's typical offset calculations. So I'm just going to go with the 1/4 inch again. And then a 1/4 inch down. And what you will find is that when you're doing a 45-degree angle on a vertical stack, you'll find it to be about 60. So you can create a rule here if you want. Diagonals off the vertical can be drawn at 60. I don't know if it's going to work quite so well on the other side because you get some perspective shift here. I suspect this one's going to be 45. Yep, close enough. I'm going with close enough. Obviously, I could use the measurements. Nope, that's it. I'm going with close enough just to make my life easier. But you can just go from tick to tick. I think it's important to point out that isometric drawings are also called artistic renderings. So there's tons of artistic license when you're doing isometrics. As a matter of fact, in reality, when you tip something, when you turn a box towards you, and then flip it up at 30 degrees, the lines appear to get about 20% shorter. There is such a thing as an isometric scale that we're not using. It would make our drawings more accurate. So you can see how that's starting to come together. Now let's do the next one. So it's going to be the same, which was 5/8 up from the bottom. Oops, get the right scale here. So we have 5/8 up from the bottom. And then we had, what was it? Oh, 1 3/8. Is that all we did? And then 1 3/8. Oh, we're not quite tall enough for this one. And for this particular stack, the lowest portion, so this is stack A, D at the bottom ran to the right. C ran to the left. And AB ran both directions. The distance out, what distance did I do? Ugh. I did 1 5/8. So 1 oh, we're going to have a pipe crossing over here. 1 5/8. 1 5/8. 1 5/8. 1 5/8. And then again, we're going to back off here 1/4 inch. Back off there 1/4 of an inch. So again, I'm just drawing it square first to begin, and then I'm cutting the corner. So there we go. So I'm using the 60-degree triangle here. And it's not exact. Unfortunately, isometrics, nothing is ever exact. And then I'm going to use my 45-degree triangle going the other way, because it was actually I'm going to go as the crow flies on this one. There we go. The other one I used 45 degrees here, but it was off by about 3 or 4 degrees. So you have to decide which pipe is in front of which. And because this one is closer to me, the viewer, I'm going to break. It's called an interference fit. I'm going to break this line as it goes across underneath stack B. So stack A is a little bit further away. Yep. And I'm not going to say I'm right with this. I suppose you could look at it the other way, almost like they can make contact. I have to think about that one. These are theoretical drawings, so maybe they never thought about having these drawn into converted to isometric. Again, don't forget to sharpen your pencil as you go. Just give it a little twist. And go ahead and erase all the excess. So there you go. I've got this one just a little bit lower. I'm not sure that that's right, but that's called, you had to pick one to go over and one to go under. So it happened to be a random selection for me, but there you go. Stack A was under. My detail box was very subtle, to be non-existent, although it helped me with my spotting. I've included all the fittings here. They're all drawn separately. I could make my material list now. There's 2 double Ys, 1, 2, 3, 4 single Ys, and so on. 1, 2, 3, 4, 5, 6, 7, 8 45s, 9 45s. There's another Y. Anyway, it's a 90. So you could go on and make your material list. Also, this diagonal pipe looks vertical on my drawing when it's actually 45. It's important to know that if we'd gone the other way, and put something in here for a stack, had you backed off here and here, it would have looked horizontal, even though in reality that would be a Y and a 45. So those diagonal pipes, once you got the detail box down, the basic shape of a box and the things that go in it, you're fine. But when it comes to the diagonals, you have to know they can be horizontal looking, they can be vertical looking, they can be 60, virtually any angle. But basically, or they can be any angle, but look for horizontalish, verticalish, 45-ish, and 60-ish. But they are artistic renderings. Anyways, I hope that was helpful. Yeah, and that's it. Thanks. Any questions, let me know. That's drawing number 22 in your introduction to the second half of pipe drawings.